Hello everyone, my name is Paul, Oscar Mike Zero Echo Tango, and welcome to this new video about the radio frequency signal source. I bought this signal source from the Banggood and it was pretty cheap. I think I purchased this equipment for 90 euros from the Banggood, from the China's warehouse, and I'm pretty happy because it is very helpful tool for my experiments in my lab. So here you can see how this equipment works, how it looks like, and maybe for what purpose you should use this little radio frequency source. So, as you can see, the body or the enclosure of this equipment is made of plastic. There is no metal or any metallic enclosure, just the plastic. Here on the bottom side is foldable stand, which can be used in this way or in this way. Yeah, which is quite practical in my case when I can use the stand like this. Well, the front panel is made of something like a machined PCB board, and you can see here on the front panel the hard button, the power switch, the BNC socket, output BNC socket, and numeric keyboard. The radio frequency source is working from 0.5 MHz to 470 MHz range. I don't have any measurement equipment for the VHF and UHF bands, so maybe I could see what the signal looks like on the HF. Actually, I bought this equipment for my HF appliances, so I don't need the higher frequencies, more than 30 megs. So let me power up this thing and we'll see how it works. I want to use the MCHF transceiver. I want to input the signal from the RF source right into the SDR transceiver. I will see the signal on the screen, how it looks like, and I will test the sensitivity, and I want to test the S-meter calibration on this rig. Okay, so firstly, set your power source to 12 volts, which is the nominal voltage for the RF source. So 12 volt is quite okay. And when I switch on the the RF source, the power consumption of the RF source is just 80 milliamps, which is quite low. Okay, when turning on, a voltage appears on the screen for a while, and then we can see all informations. So here on the upper left corner you can see the output frequency, right upper corner is the strength of the signal, lower left corner is subtone frequency, and here is the audio output frequency. On the right lower corner we can see the firmware version. So now I have a short manual from this equipment, so you can read right here that the accuracy comparison between the signal source and professional compressive measurement is basically the same. Oh, I'm very curious. The accuracy is very high. Can test the actual receiving resivity, sensitivity of the radio. Units are in dBm. Well, we can show you now how this equipment works. So, as you can see here on the right side, we have a numeric keyboard, which is very useful for this purpose, because we can input frequency directly from the keyboard. Let's say 7.100 megs, so 007.100. So now we are on 7.100, and we can use the F1 button and we can change this arrow what we want to set. So now we can see the arrow shows to signal strength. Also we can change the value directly from the keyboard, or we can use this up and down arrows here, buttons on the bottom. If we press the F1 button again, the arrow appears and we can change the audio output frequency from 1 kilohertz up to 3 kilohertz or 0 kilohertz. By pressing F1 again, we can set now the subtone. This equipment allows to generate the audio subtones, or also the digital subtones, which calls the CTDC subtones. If we want to use audio subtones, just input frequency, let's say 88, no, we can use F2 like backspace. So again, 088.8. This is the audio subtone, and if we want to use let's say digital subtone like 23, so we can put inside the 023 and press the F3 button here. Now we are on the digital subtone, and we can change the N or I by pressing F2 button. Okay, so that's how it works. And now I will connect this generator into my transceiver, and we will see how it works in real conditions. Okay, so for connection, I will use this little piece of BNC cable between my transceiver and the output from the RF signal generator. And connect it into my transceiver. Okay. So now you can see that I set 14.2 megahertz, and signal strength is set on 0.72 dBm, which should be 9S unit by the international table. Okay, so I will turn on my MCHF transceiver. And actually we don't hear any output noise. Yeah, it's because the signal is so strong coming out from the source. When I switch off the signal source, we hear just the background and RF source is turned off. So you're back, power on, signals there. You can see very strong signal here in the background, and you can see also the green dots, which means that the signal strength is now about maybe 8 S units. Okay, so now I am in USB mode, which means that if I tune my transceiver 1 kilohertz away from the carrier frequency, I should be able to hear the 1 kilohertz audio signal. Okay, so when I go 1 kilohertz to the side, I will hear 1 kilohertz tone. Okay, the signal from the power source is not modulated right now, but I can go to audio setting here with F1, and now I will set 1 kilohertz, and now the signal is modulated, and you can see this signal here on the screen. We can change the frequency to 2 kilohertz and 3 kilohertz. 2 kilohertz, 1 kilohertz, and 0. So we see only the carrier here on 14.2. Okay, and now I will show you how the Subtones works. So I go to Subtone settings here, and I will put inside the 88.8 audio subtone. So I will input this value directly from the keyboard. Okay, this is 88.8, but I'm not, I'm on the frequency. This is how the Subtones looks like in SSB modulation. Now if we go to use digital, so we can input 023, let's say, and press the F3 button. Okay, now you can hear the digital subtone in the background of my signal. If you use a 0, 0, 0, it will be switched off. Okay, so the second test will be to see how the signal strength and sensitivity of the receiver works. So now we are set on 0.72 dBm, which means it should be 9 S units. And we have to turn my transceiver into FM mode. So I go to mode and FM mode. Okay, this is FM mode. So we don't hear any noise because it's the full signal from the RF source. And now I use the F1 button again. Appears the arrow here, and we can adjust the power strength. If we go up, which means that the signal go down. So we are going up, and the signal here on the screen, it should be weaker and weaker. And we should be able to hear some noise from the receiver. Okay, 132 is the minimal signal power from this generator, and here on the receiver we are not able to picking up any signal from the power source in this moment, but we have to use audio modulation. So we have to push the F1 button and here select the audio frequency. So we will modulate the signal by 1 kilohertz, and now we will be able to recognize the signal in the noise. And when we will hear the signal 100% okay, that's the lower lower level of the sensitivity of this receiver. So let's go back with the strength, and let's see when the signal will appears in the receiver. Okay, I hear something right now. 123 dBm. This is 120, and the signal is clearly hearable. And this is very clear now, 115 dB. And of course, it's loud and strong on S9 bag again. The maximum value is 0.70 dBm from the power source, from the RF source. Okay, so in the next part of this video, I will show you how this RF source looks like inside. So let me open the box and I will show you how it looks like inside. No. Okay, so here we can see interior of this RF source generator, and yeah, it all is fixed by the hot glue or hot gun glue. I don't think it's ideal, but everything is there with glue. And now it explains why is the front panel made of the PCB board. Because the electronics is right there. As you can see, it's fixed, soldered to the PCB board. So the PCB board of on the front panel is from the second side a part of electronics. And here on the background it's the generator, but I don't see what is inside because of the glue. But I want to see. Okay. Let me unscrew the main board and see what is there. Okay. So this is the electronic. You can see the parts. I try to zoom in. It's a 5-volt stabilizer. Processor unit. I think it's attenuator. Okay. Oh, it looks pretty simple, but efficient, don't you think? Thank you guys for watching this video. If you want to see the link, you can find the link in the video description. And if you like my videos, don't forget to subscribe to my channel. Thank you very much for watching, and 7-3, bye bye, good luck.